Hi everyone, welcome to another video on my coding practice to prepare for the Google Tensorflow Developer Certificate. Previously, I have done 2 videos on my coding practice on computer vision for binary and multi-class classification. If you haven't watched my previous videos, be sure to check them out. I will link them in the description box below. In this video, I will be moving on to natural language processing, or NLP in short, to predict texts. Just a reminder, do note that the certificate that I am preparing for is the one that is to end as of May 2024. Again, I will be coding on Google Colab instead of PyCharm, as personally I feel that it is easier to display and show intermediate workings instead, but the code should work in PyCharm too. I have shared the link to the code in the description box as well, so you may follow along. We will be covering some key concepts as laid out in the candidate's handbook. They are: to build natural language processing models, prepare text to use for models, use word embeddings, and lastly to train LSTMs or GRUs on existing text to generate text such as songs or poetry. As usual, let's import the libraries that we will be using today. You may notice a few new methods, such as categorical, tokenizer, pad sequences, and embedding. These are specific to natural language processing, and we will be using them in our code later. Lastly, we will import SSL as well to resolve any certificate issues if you are running this code from the computer. After the libraries are downloaded, we will have to download the dataset as well. We will be using Shakespeare's sonnet as our dataset, and we will train the model on it to predict words and to create its own sonnet as well. We will now inspect the file. We will read the saved text file and convert all the letters to lowercase and split them by lines. We can print to see the number of lines in the sonnet database and to check the average number of words per line. We can also print to see how the first sonnet looks like. As we can see, the English they use is not modern English and it's Shakespearean English. Now, we will tokenize the text. We will fit the text to the corpus, which will assign a number to each word in the database, and we will increment the total number of words in the lexicon by 1 as the starting number of the word index is 0 and not 1. We can inspect the sequence of the first line as well. As we can see from the results, they have been converted to a list of numbers. Next, we will create a function to generate n-gram sequences. This will help in the model's understanding of context based on surrounding words. We can also print the results to visualize how the results look like. We will now apply the n-gram sequence on the corpus. Next, we will pad the n-gram sequences which we created earlier. This will help to normalize the sequences such that they are all of the same length. We will apply the padding with pre so as to allow model prediction for the next word. If the padding is applied with post, the model will predict on the padding, which is not what we want. We can visualize it below here. Once we have the function ready, we can proceed to apply the padding to the entire corpus as well. Next, we will create a function to split the corpus into features and labels. The features would be the padded n-gram sequences which we created previously, and the label would be the next word to continue in the sentence. We would apply one hot label encoding to the labels so that we can use categorical entropy as our loss function in the model later on. We can print to inspect the shape of a sample label and to view the first features. The last step to pre-process data is then to apply the previous function to the corpus. Now, we will create the model. We will start with an embedding layer of the corpus and add a bidirectional LSTM layer, followed by a GRU. We will then end off with 2 dense layers. The arguments passed into the compilation method are nothing too uncommon, and we can proceed to train the model. This is going to take some time, so I will skip the training here. That took quite a while, but the model has finally completed training. At the end of 30 epochs, the accuracy is hovering around 82 to 83%. You can train it for longer if you like, but in the interest of time, let's continue. Now, for the moment of truth. We will use the model to predict texts, or actually more like to create an entire sonnet from a seed text. I will feed in a seed text line by warm loving embrace I seek, and see what it comes up with. Based on what I have seen, a sonnet has 13 lines, so I set it here. Remember the average number of words from earlier? We will use it here to set the number of words per line of sonnet. Next, I will iterate it over the range sonnet lines, and for each word, we will predict the next word with the highest probability, and append it to the line which the model will iteratively predict the next word based on the initial line and the predicted first word, until it gets to the end. And there you have it. A full sonnet created from the model based on an initial seed line. Some lines might not make sense, but you can see that there are some Shakespearean lines in between. And that's the end of this video. To summarize, we have covered the key concepts of building a natural language processing model. Prepare text to use for models. Use word embeddings. And lastly, to train LSTMs or GRUs on existing text to generate text such as songs or poetry. Hope that it is useful to you as a reference. So, what are your thoughts on it? Feel free to comment in the comment box down below. If you liked this video and would like to see more content of this nature, please be sure to like and subscribe as well. Thanks for watching, and until next time.